Hello guys, once again welcome back to my YouTube channel. This is Pavani Raj from SVC Department of CSCDS. So today in this section we are going to discuss on a ER diagram of a shopkeeper in database, and let us go further. So some introduction towards the database. So, introduction to database management system. A database management system is a software application that allows the user to store, organize, and manage data efficiently. Database management system ensures data integrity, security, and consistency by providing a structured way to store and retrieve the information. It serves as a bridge between the database and the end user, enabling seamless interaction with the data. So, importance of database management system. Database management system simplifies data management by providing a centralized platform for storing and accessing information. It improves data security by implementing access control mechanisms and encryption techniques. Database management system enhances data consistency and accuracy through features like data validation and normalization. So, types of database management system. Relational database management system stores data in tables with defined relationship between them. NoSQL database management system allows for a flexible and scalable storage of unstructured data. Object-oriented database management systems organizes data as objects with attributes and methods. So let us go for the components of database management system, or different types of database management system languages. So data definition language DDL defines the structure of the database. Data manipulation language DML enables users to retrieve, insert, update, and read a data. Data control language DCL governs access permissions and security settings. So let us go for the ER diagram of a shopkeeper in a database. An introduction to ER diagram of a shopkeeper in database. In an entity relationship, ER diagram is a visual representation of the entities and relationships within a database. The ER diagram for a shopkeeper database will instruct the entities related to managing a shop, such as the products, customers, and the orders. By mapping out the relationships between these entities, the AR diagrams helps in designing an efficient database structure for the shopkeeper. So entities in the shopkeeper databases are the main entities in the shopkeeper databases include products, customers, orders, and the suppliers. So each entity represents a distinct type of data that the shopkeeper needs to store, manage within the database. So products entity stores information about the products available in the shop, such as product ID, name, price, and quantity. So attributes and the relationships. Attributes are the properties of any characteristics of each entity, such as product name, customer email, and order date or an order date. Relationships define how the entities are connected to each other, such as customer placing an order for a product. So relationships are typically represented using a lines connecting the related entities in an ER diagram. So product entity. The product entity in the ER diagram of the shopkeeper database includes attributes like product ID, name, price, quantity. So the product entity has relationships with other entities such as an orders for tracking the product sales and suppliers for managing the product sourcing. So each product in a database is uniquely identified by its product ID. So customer entity. The customer entity stores the information about the customers, including attributes like customer ID, name, and email, and the address. So the customer entity is related to the orders entity as a customer's place for or as a customer's place orders for the products. Each customer in the database is uniquely identified by their own customer ID. Order entity. The order entity tracks the information about each order placed by a customer, including the attributes like order ID, order date, and the total price. So the order entity is linked to both the product entity for products in the order and the customer entity for the customer placing the order. Hence, we can say that the order entity is linked to both product entity as well as the customer entity. So each order in the database is uniquely identified by its own order ID. Supplier entity. The supplier entity manages information about the suppliers providing the products to the shopkeeper with attributes like supplier ID, name, and the contact details. So the supplier entity has a relationship with the product entity as suppliers provide products for sale in the shop, where supplier in the database is uniquely identified by their supplier ID. So ER diagram representation. The ER diagram of the shopkeeper database visually represents the entities like products, customers, orders, supplies, and their relationships. Entities are depicted as boxes with attributes listed inside the box, each inside each box, and relationships shows as lines connecting the related entities. The ER diagram provides a clear overview of how data is organized and connected within the database structure. So benefits of using an ER diagrams are ER diagrams helps in designing and understanding the database structure for the shopkeeper, ensuring the efficient data management. By visualizing entities and the relationships, ER diagrams aid in identifying potential data redundancies and inconsistencies. ER diagrams serve as a blueprint for database implementation, guiding developers in creating an optimized database system for the shopkeeper. So let us go for the conclusion of this section. In conclusion, we can say that the AR diagrams of a shopkeeper database plays a crucial role in organizing and managing the data related to products, customers, orders, and suppliers. So by representing entities and relationships visually, the AR diagrams provides a comprehensive overview of the database structure. So utilizing the ER diagrams in database design ensures a well-structured and efficient system for the shopkeeper to manage their shop operations efficiently. I hope you understood this section. Thank you.